Now we are going to discuss the model 1. So summary. So in summary, I will give the formulas, every formulas that we will be using, and later we will be discussing the class notes with the derivations that we have, how we arrived at this, and the important derivations that was given in your syllabus and in your notes. So we separate this into two: the formulas for 3D and formulas for 2D. So both we have to memorize, then only you can write use it in your problems. So both have the same thing, but slight additional thing you have to read, you need, then only you can immediately solve it. So for the 3D, first we have to write the stresses. What are all the stresses that is acting? So we will be having along x direction sigma xx, along y direction sigma yy, and along z direction sigma zz, and due to this 90 degree to the x direction you will be having tau xy, and 90 degree to the y direction you will be having tau yx, and 90 degree to the z direction you will be having tau zx and zy, like that. Zx or tau zy. So then here you will be having tau xy, then tau yz. Here you will be having yx or yz. So this complication, how to write this? X, y, z and x, y, z. So you will be having sigma xx, so sigma yy and sigma zz. Here you will be having sigma x, tau xy and tau xz, and this is tau yx, and this is tau yz, and this is tau zx, and this is tau zy. So this is written in matrix form. So this is called the stress tensor. So we have written the stress tensor. The sigma x, sigma y, everything will be obtained from strain rosettes. So this is the importance of strain rosettes. The strain rosette is a strain gauge, so that is fixed in x direction, y direction and z direction, and the change in length with respect to original length, the strain and the material property Young's modulus, we multiply both of these things, we'll get the sigma. So this is one thing. So from this you have to determine two different things, that is the maximum thing and in any plane what is the stress. So for that Cauchy has derived, so Cauchy will be asked how to derive the Cauchy formula. So this is stress. Same way you can write it for the rotation. So rotation matrix. So for the rotation matrix, same way you have x, y, z and x, y, z. If I have any x, y, z, capital X, capital Y, capital Z, and if I have any line that is alpha with the x, let this be the any surface normal to any surface, let this be the normal vector. So if it is alpha to x and beta to y and gamma to z, you can write cos alpha along x direction, so hence it is called as nx, and cos beta along the y direction, hence it is called as ny, and cos gamma along the z direction, hence it is called as nz, and cos square theta plus cos 90 minus alpha square, that is ny square, plus you can also write this as equal to 1. So always this must be satisfied. So this is how we represent nx, ny and nz. So if this is so, we will be having a rotation here. So that is cos force along x direction alpha. Then this is cos force along of the force along the x direction. So this is along this x direction, and this force is turned to this direction. So it is beta, and this is you will have, that is cos 90 minus alpha. You can write this is cos gamma. So this is already solved in your thing. That is cos, this is beta. So this is cos 90 minus beta. You will get sine beta. So this is 0 of x and z. You will be having 90 degree. The angle between x and z, you will be having 90 degree. So this can be written as sine beta, and this can be written as cos 90 minus beta. You can write it as sine alpha. Okay, and this is 0. Same way here you will be having cos gamma. This is sine gamma, and this is 0. So this is the rotation matrix. So you have to multiply these two. So the multiply the stress matrix and the rotation matrix. You will arrive at a formula, that is the resultant force along the x direction due to this x direction. Here everything is acting normally, means you have to multiply and you have to add up. So this one you can write it as, multiply these two, that is sigma xx. So this is the derivation. So we have to concentrate on the we will be concentrating on the derivation part. Okay, so sigma xx plus tau xy. So this can be cut short, and you can write this as, I neglect the sign values, sign neglected, because sign value is neglected because it will be nearer to 0 for small value. So we neglect all the sign value. If you write only the cos value, you can write the vector, that is the resultant vector along x direction, along y direction, along z direction, is equal to sigma xx, sigma yy, sigma zz, tau xy, tau xz. This is sigma, this is sigma, tau yx, tau yz, tau zx, tau zy into nx, ny, nz. So from this you can write txn means you have to multiply this one with this one. Okay, if you want ty means, tyn means you have to multiply this one, this one. So what is tz? You can write tz, resultant along z direction, is equal to tau zx nx plus tau zy ny plus sigma zz nz. So like this you can write for tx1, tx2. So I am writing that. So this is 1 tz. This is Cauchy formula for z direction. So again write it here itself, the 3D. Okay, let me complete. So txn means multiply, that's equal to sigma xx nx plus tau xy ny plus tau zx, tau zx tau xz nz. Similarly, t y power y to the normal surface, that is tau yx nx plus sigma yy ny plus tau yz and z. So you have the Cauchy formula. This is called the Cauchy formula. So you can, if they want to write the Cauchy formula, you can straight away use this to this rotation matrix and this stress vector and the stress tensor and the this one, and you can multiply it and you can write the Cauchy formula. So this will be asked in your university paper if they want the derivation to be. So one formula you have derived. So now if I want in any direction, what will be the stress? So that can be written as sigma n. Sigma n is equal to that I am resolving the t x direction along x direction, and I am resolving the t y direction along y direction, and I am resolving the t resultant force along the z direction along z direction. So I will be getting this equation. Now you know tx, ty and tz. So sigma n can be done by multiplying this. So how to write this? So then you have another one thing, that is tau n. Tau n is equal to, if you know the resultant value, you can find out the total resultant value, that is square minus the sigma n square will give you the tau n square. So you can you have to want to write the t square, so that is t square equal to square root of rx square, that is txn square plus tyn square yn square plus tz square. This is one more formula. So you have this formula, this formula, this formula, this formula. Then so you should not somehow you have to memorize, otherwise you have to do like this and take the answers out. So this is at any direction. If you want, you can determine any direction, means you will be putting nx, means that is cos alpha will be having an angle. So what is the maximum load you have to drive? So for maximum load is maximum stress is the principal stress. So for the principal stress, what is the formula? So you have to determine sigma 1, sigma 2, sigma 3. So how to determine sigma 1, sigma 2, sigma 3? So if anything is lost like this, just write the characteristics equation. Characteristic equation is sigma cube minus I1 sigma square plus I2 sigma minus I3 equal to 0. This is the characteristic equation for any three-dimensional stress. Okay, so here I1, I2, I3 are stress invariants, that is the given value, which will not vary, because for the same given value, for this given value, what is going to be the stress? So if I substitute this value there, I will find out roots sigma 1, sigma 2, sigma 3 are the roots. Here sigma 1 will be maximum, sigma 2 will be minimum, sigma 3 will be minimum, and sigma 2 will be minimax. So this, like this, we will be solving the three-dimensional problems. So for the two-dimensional, for the two-dimensional. What is the stress tensor? That is sigma equal to, you don't have the other two, so here you will be having sigma xx, here you will be having sigma yy, here tau xy, here tau yx. That's all. And you have the directions as here cos alpha, cos 9, that is sin alpha. Here you will be having sin beta, this is cos beta. So you can put the cos beta, cos gamma as nx and y. And if I take the sine value outside, I can put this as same way. Cauchy equation can be written, that is Txn is equal to sigma x. So Tx, I put the vector, that is Tyn is equal to sigma x, x sigma yy, tau xy, tau yx into this rotation. I put this as along x direction, y direction. Multiply this, you will get Txn is equal to sigma xx nx plus tau xy ny, and Tyn equal to tau yx nx plus sigma yy ny. So this is the equation for Tn, Tx and Ty. The same way you can write it for the normal direction, any direction. Sigma n equal to Txn nx plus Tyn ny. So if this is so, this can be cut short and written as sigma x, you have to memorize this formula, okay, cx sigma xx plus sigma yy by 2 minus, so it's plus, and sigma x minus sigma y by 2 cos 2 theta minus tau xy so it's a 2 page. Reduce it to 2 page. If you note down these 2 pages, you can solve any problems. Sin 2 theta. Same way for tau, you can write this as tau n equal to sigma x minus sigma yy by 2 sin 2 theta minus tau xy cos 2 theta. You have to memorize this formula, and this is obtained by substituting all the values from the above. And what is the maximum principal stress? So here the characteristic equation will be like this: sigma square minus I1 sigma plus I3 equal to 0. Okay, so here this is the characteristic equation, and the solution is, it will be having two roots, sigma 1 comma sigma 2 equal to sigma x plus sigma y by 2 plus or minus square root 1 by 2 into square root of sigma x minus sigma y the whole square plus 4 tau xy square. So this is the formula. Then you have tau n, that is tau maximum, that is equal to 2 times tau xy divided by sigma 1 or sigma x minus sigma y. So this is your maximum stress. Here you will be having maximum stress direction, that is tan 2 theta equal to, okay. So that is 2 theta is theta 1 and theta 2 are direction for principal stress. So what is the formula that we have determined for this? So this is tau means tau max is equal to, what we determine is t square minus sigma n square. So what is t equal to, you can write it from here, sigma xx plus tau xy. Here we have xy. So from that resultant t equal to square root of tx square plus ty square. So you have found these many formulas. Here nx square plus ny square is equal to 1. So these many formulas we have written. So by using this we will be solving the problem. I will pass this and take the problem now. Okay, so this is you can put this as plus. So I check the formulas because if anything is written wrong, because I have not derived it completely, the derivation will be added discussed later, because today we will be concentrating on how to use this, how to solve all the problems. Okay, so these are all the university questions, right from whatever things, and this is taken from advanced mechanics of solids. Okay, because some questions are were solved and some repetitive and easily doable problems were being left out as places. So but today we'll discuss all the problems. Okay, this is the first module. So they have given you the stress tensor. Okay, stress tensor is given. This is sigma xx, this is sigma yy, this is sigma zz, tau xy, tau, everything is given. Find the stress. This is nx, ny, nz. You can solve this. I have already solved this here, and here you see a displacement problem is there for 2D plane stress. So we have to solve that. So let me solve this one. So how to solve this problem in glass space? Pause it a little bit. Okay, I have added a page now. So now you can solve this problem. So this is the problem we are going to solve. They are given the u. Okay, so before that I give a small introduction. So what is the displacement, how you have to write it. So for the strain tensor, you have epsilon xx. Epsilon means you will have gamma xy, and here you have epsilon yy, and here you have gamma yx. Okay, so gamma xy into 1 by 2 is equal to epsilon xy, and the gamma yx into 1 by 2 is equal to epsilon yx. So you can substitute this here and you can write it down. So now what is epsilon xx? That is the change in displacement along x direction with reference to the x direction. What is epsilon yy? The change in displacement along the y direction, that is v divided by. And what is gamma xy? So gamma xy means I have said for x direction you will have u, and for y direction you will have v, and you write it as x direction dou x, here y direction. So this is dou u. Same way for gamma xy can write it. So if you find all these things, you can write this tensor. This tensor is the requirement they have asked. So see here, the displacement u is given. You have u, that is this one, and this is v, and as j is given and I is given, this is u and v, and you have to find the stress at point 2 comma 4, and you have to write the equations. That equation is a three-dimensional equation. We will discuss in the at the last of this video. So the class within the class notes. Now we will be solving this one, and we will be writing the stress strain tensor and find out this value. So how to do that? So I have to find out, write out the u value. U value is the u value is x square plus xy, and the v value is y square plus xy. X square plus xy and y square plus xy. So the capital U is given as x square plus xy into I, that is along the u direction, and y square plus xy into j vector is along the y direction, that is v, So what is this? Is dou. We have to find out dou u by dou x. Dou u by dou x is, you have to differentiate only with respect to x. We will have been 2x plus y. So the thing is constant. If you have anything else without x, you no need to differentiate. That is constant. It will be 0. So what is you have another one thing, dou v by dou x, and one more thing is dou u by dou y, so along the y direction. So this one you have determined, and this one you have to determine dou u by dou y. So with respect to y means you have here x. Okay, differentiating y, we will have 1, and x is the constant. So here next is dou v by dou x. Dou v by dou x is, where is v? V is here. Y square is a constant, and you have y, because x is differentiated means it is 1. Then you have dou v by dou y, so that is equal to 2y plus, what is this? With respect to y means you have x. Okay, so take the constant outside, that is x. If you differentiate y differentiate with respect to y, you will get 1 into 1, so you will get x. So what is the requirement they have asked? The requirement is, what is the strain at 2 comma 4? The x is 2 and y is 4. So substitute. So this problem is repeatedly asked, so you have to be careful. If it is 3-dimensional, you have to find out another one thing. Okay, so 2 comma 4, so 2 into 2 4 plus y is 4. So I'll write it in different color, and here equal to 4 at 2 comma 4 is 4, this is 8, and here this is x equal to 2. So here this is equal to 4 to 8, 2 into 4 plus x value is 2, 8 plus 2 will have 10. So this is what I am substituting this value 2 comma 4 there, where x equal to 2 and y equal to 4. Okay, y equal to 4. You know that. So substitute that, you'll have this value Now write down the strain tensor. So this is gamma. So you have to divide it by 2, then only you have the strain tensor correctly. So what is dou u by dou x? That is 8. What is epsilon yy? That is dou v by dou y. Dou v by dou y is 10. What is this one? Half of gamma xy. Gamma xy is, we have to add up dou u by dou y, that is this one, 2, plus dou v by dou x, that is 4. Okay, same way we will be having here. So it is 6 over 3. So this is also equal to 3. So you have the strain tensor as 8, 3, 3, 10. So this is the strain tensor. Using this strain tensor, you can find out the stress tensor if you want. You have to multiply the strain with E into strain tensor. Get using the strain tensor, this is the xy direction. Z direction means you will have xy z direction. Here you have only x and y. So this will be also x and y. So by measuring the strain, you can do this. This is the next one. So this is not required. It's not questioned. Same way, go to this problem. The state of the stress is characteristic. Whether I have solved this problem? Yes. The state of the stress is given by so what they have given is, they have given the strain sigma xx, sigma yy, sigma zz, tau. So they want to find out the sigma 1 value, sigma 2 value, sigma 3 value, then tau max value, that is sigma 1 minus sigma 3 by 2. So they want to want us to find out that. Again, one more problem is there, that is this one. So I just differentiate with this displacement field. Here you have I, J and K. So we do this problem again. So here x square. So this problem is already solved in your class note. So while discussing the class note, we can do this. This is also solved in your class note. So okay, we do this. So whatever things it's given, first we have to write. What you have to write is, you have to write the characteristic equation. Then you have to find out I value. I11 is sigma xx, sigma yy plus sigma yzz. I2 value is sigma x, then 2 you have to multiply 2 sigma x, sigma y, then sigma y, sigma z, then sigma z, sigma x. Then you have to subtract two values, that is tau xy square. So square means tau xy square, then tau yz square, tau zx square. Substitute all the values from here. You will get I2 value. Then what is I3 value? You have to take three values, x, y, z. Then you have to subtract. If you put sigma x means you have to put y, z here. Then sigma y means x, z here for tau. And z means x, y, tau x square. And you have to add this one, 2 times tau xy plus tau yz plus tau zx. These are all the formulas you must memorize. If I have found out this one, I will get this as a equation, this 3-dimensional equation. So this polynomial, so of 3 degree. So we will be having 3 roots, that is sigma 1, sigma 2 and sigma 3. How to find out these 3 roots? So this is 25.61, this is this one, this one. So I can go to a calculator and change the mode. I will do it in the calculator and I will show you. We pass this into it. By using the calculator, you can solve this equation. So how to use this equation? So go to your calculator. your calculator. So where what you have to do is go to the mode and you scroll down. You'll have ax cube plus bx square plus cx plus d equal to 0. So anything nearer to x cube is a, x square coefficient is b, x coefficient is c, and last one is the constant. Select this one. So you have ax square plus bx plus cx plus d. So a is, in our problem, it is 1, that is sigma cube plus equal to, then b is minus 25.61 equal to, this is plus 159 point, you can see here, this is plus 156.49. so I go there, 156.49, 156.49 equal to, then you have the d value as 91.12, whether it is minus or plus, see that. So it is minus 91.92. So you have to put it here, minus 91.12, minus 91.12 equal to. So you have this. At last you just press the equate equal to, you will have this x1 value, x2 value, and x3 value. X1 16 point, so 10 power minus 16 is negligible, so I can take x1 as 16.41, x2 as 8.54, and x3 as 0.646. so this is the way you can calculate in your calculator. So I have used some other way and I have solved this. So 16.41, see here, 16.41, 8.53, 0.64. I show it in the calculator also. See here, you take these values equal to, the sigma 1 value is 16.41, sigma 2 value is 8.55, sigma 3 value is 0.649. This I value is 10 power minus 16, that is 0.0000000000016 times value. It is negligible, so we can remove this complex value. So this is the way you can solve it using the calculator. By solving it using the calculator, I have determined sigma 1, sigma 2 and sigma 3. Then what is the maximum stress? Maximum stress is sigma 3 minus sigma 1 by sigma 1 minus sigma 3 by 2. This is the maximum shear stress. So this is the way you can determine the answer for the first problem. So they have asked the maximum stress, principal stress. So if they have given the angle, you can determine the thing. So I extended the problem to find out the plane for the maximum stress. To find the plane for the maximum stress, you have to consider this sigma 1 value itself and substitute in the given stress. Given stress is this one. Substitute in that given stress the sigma, that is 16.4 value, and minus here, subtract here, subtract here. We subtract those values along the diagonal, multiply this. Always cos 0 is 1, cos 0 cannot be made be 0, hence we solve this equation, that is this sigma x minus sigma is put to 0 and the determinant value is can be used. So this is the cofactor value. So a1 is the cofactor of 4.09. Cofactor of 4.09 is cofactor of minus 4.09 is you have to take these two values. So these two values you have to multiply this and this. So I have written that. So it is 12.66 into 7.44. As we have minus and minus, it becomes plus, then minus 5.22 into 5.27 to 5.27 at 66.42. What is the cofactor of this one? This one. So this is the second value, you have to put minus here, so that's why you have minus here. Then you have to multiply these two and these two. So this one, so it is 4.2 into minus 12.06 and minus of 5.2 into this one, you get this value. Then you have one more cofactor, that is C, that is for 0.84. You have to multiply these two, so that you have written 4.2 into 5.27 minus of minus 7.44 into 0.84, you get this value. So you have these three values. Now you have to find out nx equal to 66.42 divided by, you have to square it and root it. Square of 66.42 plus square of 58.4 plus square of 22.1, and you take the root. This is nx value. Same way you put b here and c here, you will get the three values. If you want to check the answer, you square it and equate it, it will be nearer to 1. You again you can check the answer by finding this one. So I1 is equal to sigma 1 plus sigma 2 plus sigma 3. Okay, sigma 3. So you can add it up, and this will be equal to you have the equation as ax square x cube plus bx is substituted in plus cx square plus cx plus d equal to 0. So this will be equal to minus b. Okay, same way you can put sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1 will be equal to c. So if you know the values, if you just multiply this, and if you want to check whether sigma 1 sigma 2 and sigma 3 obtained by using the equation is right or not, using the calculator right or not, you have to multiply. You just add it and see whether it is equal to minus 25.41. what you have got, 16.41 plus 8.5 plus 0.6. you add it up, this is near to 25.61. so you have to put minus b, so then only you can put equate it to 25. so this is how you can check this, and for the angle you can check this using this value. So when you get out of the hall, you will definitely know the answer, and you can check it out in the exam itself. So what is the significance of stress variance? Stress variance of the given data, that is the strain, using strain rosettes, you will be you can determine the different direction, so that we have discussed here. So this is the strain along different direction that can be converted to stress, and from that stress you can determine all the stress along x direction, y direction, or any angle, normal stress, and the maximum stress. By finding the maximum stress, you can check it with the theory of elastic failure and design your material pressure, material diameter. So this is the way, and choose your material, what material you have to choose, that you have discussed in the module 5. So here one more problem is here. I do this also because it will be easier once you have this solved, because you should not make any mistake in this differentiation. So for that I will be doing this one. Okay, so you have this equation repeatedly asked in your question. So you have a strain tensor that is equal to epsilon x x gamma xy. So if you put x y z, you can put x y z, x and x and y. This is x and z. So here you can put uh, gamma y epsilon y. This is epsilon z. This is gamma y z. This is gamma yx. This is gamma zx. This is gamma zy. All these things you have to find out. How to find out? You will have 10 marks for this. Okay, nearly. You can zoom it out. So what is epsilon xx? Epsilon xx is dou u by dou x. What is u here? This is the first one. So 2y square plus 4y z. You don't have any value with respect to x. Okay. Yes, zoom it out. Let's check the problem. 3 plus 5x square k is there, and this is I, and this is j. They are given 2y square I plus 4yz j. So this is dou of 2y square by dou x. So you don't have any x value here. This is equal to 0, hence this is constant. Then epsilon yy equal to, this is j vector, where j vector is, you take it as, so dou v by dou y, that is equal to dou of, you have yz. So you have the value of, if you differentiate it, you will have the value of y is differentiated into 1 z. So the z is there. Then epsilon z equal to dou w by dou z. This is equal to, z is 3 plus 5z square. So zoom only. So this is equal to dou of 3 plus 5z square by dou z. This is equal to, you have z here, 3 is 0, 2 z. So 5 to 10, 10 z is the value. So you have three values. These three values you have to determine. Now I have to determine the other thing. I do it in black, then only if you take a printout it will be easy. Now you have to do it in gamma xy. Gamma xy is equal to, you have to put u, you have to put b for y, and put dou x xy. So reverse it, dou y dou add it. Then gamma yz is there, that is equal to dou y is b and z is w, and it is yz, so y z put dou and add it, and gamma zx is equal to, z is w, x is u, and you put z x, you put dou plus dou. Okay, that's all. So what is dou u by dou y? Dou u by dou y is, dou u by u is zy square by dou y plus dou v by dou x. Dou v by dou x, dou v is yz by dou x. Okay, so with respect to y you get this is equal to 2yz plus with respect to x you don't have any value, so 0. So this is dou of b is yz by dou z plus dou w is dou of w is 3 plus 5z square, 3 plus 5z square by dou y. So you get the value of this one equal to, with respect to z you get y, with respect to y you don't have any y, this is 0. So the last thing, dou w by dou x, you find it out, you have all the equations, you have to substitute. So I substitute that too for this. Okay, so I write here y equal to y. So what is this one? Equal to dou w. Dou of w is 3 plus 5z square, so this will be definitely 0 by dou x plus dou u. U is zy square by dou z. You have z there, so you get 0 plus y square. Y square is constant. If you differentiate z, it is 1. So we have this value, this value, this value, and here this value, this value, this value. Substitute all these things in this tensor, that is the strain tensor. So determine the strain tensor. So that's all for this. Octagonal stress means nx equal to ny equal to nez. Okay, so this is not in your syllabus, they have not concentrated this, but I have given this hint for all these things. So how to determine that? If you want to determine the stress, this is equal to, if I put nx square plus ny square, I already solved it in the class, nx square plus nx square, instead of ny square I can put nx square itself plus n z square means nx square equal to 1, so it is 3 times, so nx equal to 1 by root 3. You have to substitute every value as 1 by root 3, and you have to multiply sigma with 1 by root 3, 1 by root 3 and 1 by root 3. You get the value of the octagonal stress. Okay, at any angle you can change the angle of this one. Okay, so again you have this 6 stresses in principal plane, and for this the output is 0, so we'll solve this now. Okay, so this one already we have discussed 2 problems, so this will be given as assignment. Okay, very good. I do this problem now. So most of the problems I am solving, you don't watch only the video, just you do this in your notebook, because 1 hour I am writing and teaching. You are also you must also write. So sigma equal to, spend 1 hour, get 20 marks. So sigma xx is 0, sigma yy is 0, sigma z is 0, tau xy is 10. I am covering all the problems, so tau xy, here tau yx is also 10, tau xz is minus 10, so this is tau zx minus 10, then tau yx, tau yx is, this is y, this is x, yz is there, yz is 20, so zy is 20. Okay, so they have given this stress, they want us to determine I1 equal to sigma, and only for sigma 1, sigma 2 we have to write like that. Here you have to write like this, sigma x plus sigma y plus sigma z, and that is equal to sigma x is 0, sigma y is 0, sigma z is 0. So I1 is 0. They want us to determine the stress invariance. what is stress invariant sigma 2 that is I2. Wait a second. Is equal to sigma x sigma y. But to take 2 at a time, sigma y sigma z and plus sigma z sigma x minus tau xy square minus tau yz square minus tau zx square. So this is one thing, and you have to find again I3. These are all the values. I3 equal to 3 take at a time, sigma x sigma y sigma z. So this is not sigma 1 sigma 2 sigma 3. So for sigma 1 sigma 2 sigma 3 you don't have put tau. Then you have minus, take 3 at a time, so tau and put sigma sigma x is there means y z of tau square minus sigma y is there means tau tau zx square minus sigma z. You have z means xy, this is tau xy square, then plus 2 times tau xy tau yz to tau zx. So I have three things, I1 I2 I3. You have this value sigma x sigma y sigma z. So one thing is 0. What about the next thing? So shall we substitute? So sigma x is 0, so this becomes 0, and sigma y is 0 0, sigma z is 0 0. Here this is tau xy is this one, then tau yz is this one. So tau xy square is 10 square, that is minus 100. Tau yz is 20 square minus 400 minus tau zx is minus 10 square, that is also 100. So you have minus 600, that is I2. So again this will become 0, this will become 0, this will become 0, because all y z x everything is 0. Only this one is here, that is 2 into tau xy is 10 into tau xy yz is 20 into again tau zx, this is z, this is x, that is minus 10. So you have 2 into 200 2000 4000, that is equal to minus 4000. So this is the stress invariance. We have found out stress invariance here. Characteristic equation, what is the characteristic equation? So the characteristic equation is equals of the principle of the 3D stress is sigma cube minus of I1 is 0 times I1, 0 times sigma square, 0 times sigma square, because I1 is 0. So I put it like this. First I write the equation, then we write the solve this. I1 sigma square plus I2 sigma minus I3 equal to 0. Substitute all I1 I2 I3. Sigma cube minus 0, sigma cube minus 0 plus I2 is minus 600, so you get this as minus 600 sigma. I3 is minus of minus, you get plus 4000 equal to 0. So So this is the stress invariance. So stress invariance and characteristic equation. What is the principal stress and the principal plane with respect to the maximum stress? Find out sigma 1 comma sigma 2 comma sigma 3 equal to how much? Shall we move to the calculator? So this is of the form ax cube plus bx square plus cx plus d equal to 0. So what is the a value? A value is 1, b value is 0, c value is minus 600 and d value is 4000. So substitute here in the calculator. If you don't have the calculator, please get it. Otherwise, come to me. I will give you alternate method. That will be a little tedious one. So a is 1, b is 0 equal to, delete it, b is all clear. A is 1 equal to, b is 0 equal to, c is minus 600 equal to, d is 4000 equal to. So now we press equal to again, get x1 20, x2 minus 27.32 and x3 7.32, x1 20, 27.32 minus 7.32 plus. So we got the answer. Sigma 1 equal to 27.32, the maximum value. Okay, sigma 2 equal to 20, intermediate value, and sigma 3 equal to, I think something is minus, so this is minus now, so this will be sigma 3, and this is sigma 1. Sigma 2 is equal to 7.32. I check the answer again. Yes, 7.32 is plus, 20 is plus, this is minus. The least value is sigma 3, so least value is minus 27.32. So now if we want to check, means you can check whether this sigma 1, sigma 2, sigma 3, you add this, you get equal to 0. What is I1? I1 is 0. That's all. So add sigma 1 plus sigma 2 plus sigma 3 and equate it to 0. I have written here. I will show that. Now only I wrote. Here it is. Sigma 1, sigma 2, sigma 3, and you can multiply and you get the value of I2, that is coefficient near to I2, and I can multiply 3 at a time and you can get that too. So shall we check? So 3 at a time. Sigma 1, sigma 2, sigma 3 must be equal to, what is C? A, sigma 1, sigma 2, sigma 3, I multiply that, 27. So we go to the normal mode. And here, how to go to normal mode? Go to normal mode, and general calculation. Okay, 27.32 into 20 into 7.32 equal to 4000. You have the minus 27, you get minus 4000. So by this you can usually check whether you have found in the calculator the correct value. Okay, so it is correct. So even though it's a university problem, without reference you can check it out. There's no need. So we have determined that sigma 1, sigma 2, sigma 3. So now they are asking us to determine the max with respect to maximum stress. What is the plane? So what is the plane? So you take sigma 1 as equal to 20 and you subtract with respect with sigma x. What is that? Sigma x is 0, 0 minus 20, 0 minus 20, 0 minus 20, and here you have I think 10, 10, here you have minus 10, I think here you have 20, 20, here you have minus 10. So see here, I have not written anything else, I have written only this one, minus 10, 10, 20, 20. Instead of 0, we subtract it with the maximum stress. So this should be equal to 0 means when this is equal to 0, you determine the cofactor of, that is a1. a1 equal to the cofactor of this one, that is minus 20 into minus 20, minus 20, 20, then 20, minus 20. So minus to minus plus 400 plus 400 minus 400, you get it as 0. So what is b1? b1 is cofactor of this one. You have minus of 10, 20, minus 10, minus 20. So this is equal to this is minus to plus minus 200 minus 200 plus 200, you get 0. So then you have c1 equal to, so simple problem we have asked instead of this using this calculator. 10 minus 20 minus 10, 20, so 200 minus 200, this is also 0. So all the value was 0. So you have square root means that is also 0. So nx equal to 0, ny equal to 0, and z equal to 0. So nx means that is equal to a by square root of a square plus b square plus c square. So if I put all this value, it is 0. So all the alpha, beta, gamma are same. So that is equal to cos alpha equal to 0. When alpha equal to 0, that is 90 degree. Alpha equal to 0 degree, and beta is also equal to 0 degree, and gamma is also equal to 0 degree. So as all the angles are equal, it is can also be called as octahedral stresses. Okay. So this is the plane where you will be having. What this means, you don't have any inclination for the principal plane. All the planes are having the same direction of x, y, and z. That's the meaning. That's why you don't have any variations. Okay. All the angles, alpha is 0, beta is 0, and gamma is also 0. So this is the question they have asked in the university, and we have solved it right now. So if you have, you can also check it by squaring it and equate it to 1. So nx square plus ny square plus nz square, equate it, we will get 1. 1 square plus 1 square plus 1 square is 1 plus 1 plus 1 is equal to 3, that is 1 by root 3 will get. Nx equal to 0 means get x square. Let me check this again. 0 and x equal to 0, x is cos alpha equal to 0, cos alpha is 0, get 1, 1, 1. We have 1 y equal to 0 degree, 1 y is equal to alpha equal to 0 degree. So you have to have this value nx square plus ny square plus nz square equal to 1, that is cos square 0, 1, and then solving this we see that nx and y and z are all 0. If I put nx square plus ny square plus nz square, nx square plus ny square plus nz square, that should be equal to 1. But here nx is 0 plus 0 square plus 0 square plus 0 square, that is equal to 0, which means that you don't have any stresses along the x, y, z direction. That's why it is having like this. the optimal stress value is 0 here. That is the sigma 1, sigma 2, sigma 3 will be the maximum stress, but it is not along the XYZ direction. It is normally something like a shear stress, because you have only the shear application here. That's why initially we don't have the value along the diagonal, so that's why it will be having a shear stress, hence you have this value. Okay, so using this we have concentrated on all these topics. Planes maximum principal stress is sigma 1, that is 20. We go to the next problems of these models. So memorize this: sigma xx plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta minus tau xy sin 2 theta. Then this one, sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. So this is the thing. So we have already given the summary of this. Okay, I will give the summary. So I'll show you the summary of this. Always take the things, formulas from the summary. Don't read it, because those derivations were not compared with the original. That's why. So here we have the summary. So this is the summary. This is tau plus xy, and here minus tau xy cos 2 theta. So take that formulas, and we are going to solve the two-dimensional thing now. We have concentrated everything in three-dimensional before, now two-dimensional. For two-dimensional you can also use the MOS circle. So maybe I may be running extra time. You can run this video a little bit faster at 1.58, and you can get the thing covered in 1 hour. So here, where is this? This is in torque and moment. So this I have to teach you. I will be teaching that. I have added it, but this is in third unit. We have to determine this m by I equal to E by R equal to FP by Y, and T by J equal to C theta by L equal to Fs by R. So these formulas I have to give the derivation. Then only you can apply this. They have given the torque, means torque is known. Then using the torque you have to find out the this what you need stress value. So torque T by J into R, you have to divide everything, and you have to get here FB by Y, that you have to determine by using the moment Newton meter, and the axial forces, the thrust is also given. So you can put three values. One is bending, another one is shear is there, another one is axial. So sigma 1 is this one, sigma 1, sigma 2 is this one, and this is tau. So sigma 1, sigma 2, tau. So this problem I will definitely discuss after I give the derivation, that is from the third model. Okay, so for the series test I will not be concentrating on this, but as it is a university question, we have to discuss it. So slightly we go to the up here. 11th problem is there. We take this as and solve now. Okay, at a point in a material, the stress optimum usually, that is they are giving tensile, that is sigma 1 tensile, mean it is plus, that is the 11th question, plus 120 Newton per mm square, to concentrate on unit also, and sigma 2 equal to 40 Newton per mm square, and tau xy is given. So tau xy is equal to, take that's xy. It's not the maximum stress, only if it is a maximum and minimum we can take this. Okay, so this is 40 Newton per 40 Newton per mm square. See whether I have solved this. No. Shear stress is given. I might have solved this in the classroom. Okay, the shear stress across this plane is given. The principal stress is asked, sigma 1, 2 equal to, what's the formula? Sigma x plus sigma y by 2 plus or minus square root 1 by 2 into square root of sigma x minus sigma y the whole square plus 4 tau xy square. The formula is correct. We substitute and get the answer. So then you have this one done, and locate the principal planes. Where is the principal planes? They have asked. Principal plane is tan 2 theta is equal to 2 times tau xy by sigma x minus sigma y. So substitute this, 2 times tau xy is 40 into 2, 2 into 40 divided by sigma x is 120 minus sigma y is 40. So 80 by 80 by 80 is 1. Okay. 80 by 80 it is 1. So theta tan 2 theta is 1 means it is 45 degree. 2 theta is equal to tan 2 theta equal to tan 45. So 2 theta equal to 45 degree. So first angle theta 1 equal to 45 and theta 2 equal to 180 plus 45. 2 theta 1 equal to 45. So second angle is, you have two angles, okay. 2 theta 2 equal to 180 plus 45. So this is equal to, you will have 22.5 as theta 1 and this is 225 by 2, that is equal to theta 2 equal to 222 means 1.25. Okay, this is the angle theta 1 and theta 2. So this one we have determined, and determine the normal stress and the shear stress, the plane of 45 degree and in the anticlockwise or clockwise direction of the plane. So what is the normal stress? Sigma n equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. So substitute all the values, we'll get the values of this one. Tau n equal to sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. Substitute values. Theta equal to 45 degree, tau equal to 40 and this is 120, this is also 40. Substitute, you will get the answer, and after substitution I will give you the answer. So this is sigma x and sigma n and tau n. So this, we have completed this paper. So what is, using MOS circle they want you to determine this, how to locate and define two-dimensional state of stress. So this is the two-dimensional state of stress, and same problem is given here. So this is assignment. Okay, write a short note on strain rosette. So if you have a 3 direction x, y, z, this is inside an object. Let me take it inside an object. Okay, this is an object. This is an object. Okay, so inside any object I can have like this 3-dimensional y. If you have this, I am going to, this is a rectangular bar, a prism, rectangular prism or square, it is of square prism. So I am having this end one strain gauge, this end one strain gauge, this end one strain gauge. So using this you can resolve and find out what is the stress along x, y and z based upon the strain, that is the change in length of this, the reading that is given, the change in strain that is given. So stress equal to, stress by strain equal to, so strain into E. So you know the, if you know the material property, you can multiply this strain with respect to this one. So strain means change in length by original length. You measure this length initially, the strain length, measure this strain gauge length, let it be L. Once you apply the load, it will be having dou L, and same way this is the dou x, this is dou y. You will have the change in length by original length. You can do this. If I tilt this angle to some other way, x, y and z, and you have keep the strain gauge. If you want to change this, how to do this? We have already put nx, ny, nz, that is the angle alpha, beta, gamma. Multiply the x direction with this one, you can get the direction along x, y, z. So this way you can use the strain rosette to find the stress along the x, y, z direction, and then along the, then you can convert it to any direction and find out maximum stress. So this one is taken even as assignment, MOS circle. This one we have to do. I will do it now using MOS circle. So they have given sigma x, sigma equal to, this is the 12th problem. Okay, 12th problem 0 60 0 60 0 using Mohr circle determine the maximum stresses and its planes. So they are given sigma equal to 0 0 60 60. So this is sigma x equal to 0, sigma y equal to 0, tau xy is 60. Okay, so that's what you have given. For the Mohr circle you have to fix a point A, and from there you have to draw sigma x, that is 0, sigma y, that is also 0. You have only tau xy, so this is tau xy, this is above and below. You draw this is 60, this is also 60, and if it is meeting here, you draw a circle of 60 as a radius. You will have the maximum along the x direction. So this is from A, you measure this is sigma 1, and you measure sigma 1, that is equal to sigma 2, because you have in this direction. If I take that direction also, that is sigma, from A only you have to measure. From A it is sigma 1, that is equal to this value. Okay, and this is tau xy, so that is equal to 60, this is also equal to 60. So from so the maximum stress that is acting is this one. So let me calculate this using the formula also. What is sigma 1 comma sigma 2 equal to sigma x plus sigma y by 2, that is 0, plus sigma x minus sigma y by 2, that is also 0, then plus tau xy, that is tau xy, what is the formula? This is cos 2 theta sin 2 theta. This is the not theta. I write the sigma n here. Sorry. So sigma x, I write the formula first. That's equal to sigma x plus sigma y by 2 plus or minus 1 by 2 into square root of sigma x minus sigma y the whole square plus tau 4 times tau xy square. So this one will become 0, this one will become 0. You have plus and minus 1 by 2 square root of 4 into tau xy is 60 square. So 60 square, if I take it as a root, we will get it as 2 into 60 by 2, that is equal to 60. By using the formula I will get plus and minus 60. So sigma 1 can be 60, sigma 2 can be 1 minus 60, and tau xy is 60. So this is the value tau max. How to find out tau max? Tau max equal to sigma 1 minus sigma 2 by 2, this is 120 by 2, that is equal to 60. So if it is Mohr circle you can do, and in your if you know the formula, you just substitute, you can cross verify. So I have done 2 problems at a time. So that's all. So what is the next one? So I have given 2 assignment from this topic. One more assignment will be coming up. So see here they are asked the derivation. So after derivation only you can do that. That's the m by I derivation. So this is Mohr circle. I will do it again, this one. So this one is 60, and this one is assignment. Okay, very good. So this I might have done, I think I have not done. I will do that. I don't know how much time is left, but I am not wasting it. So using Mohr circle I will do it. One more problem. Fix a point A. So before that I draw a graph. Okay, then only it will be easy. So it is 120 and 60. I take the x-axis as 2 and 2. Okay, 2 and 2. So 2 4 6 6 8 10 12, like this. This point is A, 2 4 6. Okay, so this is 10 side. I mark from A sigma 1, that is 120, that is this one. This is sigma x, and from here I mark the another color. This is sigma 1, sigma x, and what is sigma y? Sigma y is 60. So I take another color. Sigma y is 60, 20 40 60. So this is sigma y. Now you draw tau. This is 10 side. Compression means you have to do it in the reverse direction. So this is tau xy. You draw tau xy from sigma x and sigma y. So sigma x, sigma y. What is the value? It is 30. So it is 30 means here and 2030 is here. Join these two lines, it will meet here. Using this as radius, draw a circle. Now from A, this point is the sigma 1, and from A, this point is sigma 2, and from x-axis this dimension is tau max. So tau max is nearer to 40, and sigma 1 is nearer to 120, near 140, and sigma 2 is nearer to 2040. Okay, so this is the answer. Now this is 2 theta, so they are nearer to 45 degree. Then so theta 1 equal to 2 theta 1, 2 theta 1, 2 theta 1 equal to, again another one angle is 2 theta 2 equal to 180 plus 2 theta 1. Okay, 2 theta 1. So using that we have solved this. So I given the answer. You can check this as an assignment. You check this using the analytical method also. So I have not left you without any guidance. So you have to do. Okay, here you have the shear force bending moment. Here this one, direct stress, compressive stress, and the major principal stress is limited to, I will do this problem, maximum and minimum shearing stress, minimum at this point. Okay, so now you just write the problem and the formulas, that's all. So they have given direct stress 130, that is, let it be sigma x, that is equal to 130 the point on plane at right angle to one another. Okay, Newton per mm square, resistance I, and they have given compression, that is sigma y equal to minus of 110, because it is compression, Newton per mm square, and the major principal stress is limited to, major is maximum, principal stress itself is named as maximum, major means it is sigma 1, so 150 Newton per mm square. So they are asking tau max is equal to how much, and sigma 2 equal to how much. What is sigma 1? Just write it in the formula. Sigma 1 comma 2 is equal to sigma x plus sigma y by 2 plus or minus by 2 square root of sigma x minus sigma y the whole square plus 4 tau xy square. Here what and all you know sigma x, sigma x, sigma x, sigma y, sigma 1, so you have to put only plus, don't do this, put only plus, you have to get sigma 1. Now only unknown is tau xy. From this you can determine tau xy. Once you have determined tau xy, put it for sigma 2, just you put minus here, instead of plus or minus you put minus here, that is sigma x plus sigma y by 2. So the only unknown is here, this one, you can get it, minus 1 by 2 into square root of sigma x minus sigma y the whole square plus 4 tau xy square, that's all. So the two stresses they have asked, we have substituted and obtained the answer, so that's all. Okay, what happens to the next one? Running short of time, 1 hour is the target. I don't know how many videos we have, nearly maybe 1.5 hours, not more than that, and we are concentrating all the problems now. Resistance side is put minus, same problem is repeated, shear stress, determine the principal and maximum stress. Okay, so let's okay, this problem, the construction of MOS circle, you just take it 2-3 values of your own. Sigma x equal to, you take some 10, sigma y equal to, you take some 5, tau xy equal to, you take some 4, and just you draw the circle. While you draw the circle, mark, you write the construction, how you draw those things, so, and you have the diagram also coming up, so you will definitely get this answer, and if you have drawn those circle and all, you will definitely get these 5 marks. So this one is already substituted in the class, so that one is completed. So what about this? So same thing, the bracket, shear stress is given, maximum stress student find using Mohr circle. So already I given one assignment for Mohr circle, so this is not needed. So this shear stresses to a point tensile and compression, and we have shear stresses. Substitute and find out the answer. So all the problems are the same, so you can determine it. Okay, so with this I end up the revision for this module. Take up from the summary all the things, and you do the assignment. I will publish it in any ways. Okay, thank you.